Mark P. Otten back with you. Okay, so why are we here? Why do you have to take statistics? You're a psych major. You thought math was over. Maybe you're a psych major because you wanted math to be over. Well, hopefully this, first of all, is not a math class. It's a statistics class for psychology with an emphasis on the for psychology part. So I try to really make everything applied here, make everything relevant to psychology research. And it's really like, it's the scientific method that we're working with here. So like all students graduate students for sure, get this research methods training. And it's a lot of times statistics. There's non-statistics research, like you can interview people and get what's called qualitative data. That doesn't involve statistics too much, but everything else pretty much does. So like if you're in nursing, social work, any social science, anthropology, political science, all statistics classes are everywhere. And it's part of the scientific method. Psychology research follows science. So what does science look like? Well, it's this process where you have an introduction, then you have a description of what you did in a research study, then you have the statistics, typically, and then you have the discussion at the end, which is your conclusion. So this process has been sort of agreed upon by humans over the last 150 years as the way to get academic work, get new knowledge out there in an organized way that has a structure that is respected across universities and across businesses and everywhere. So, for example, where would the stats fit in by this silly little example? I hypothesize, well, this is not silly at all. This is completely true. The more statistics you do, the more fun you will have. Absolutely proven. Well, you can't really prove anything in science, but this is totally an accurate hypothesis, if you ask me. All right, so suppose we want to test this hypothesis. I ask a bunch of you psychology students how much fun you're having after you've done a certain amount of statistics. And then I have you do more, and then I ask you again, let's say. We gather a bunch of data, and so we have like one column of data that's fun, and another column of data that's statistics, like the amount of statistics that you've done. 2 columns. And then you could perform a correlation, let's say. The higher the number on the correlation, the stronger the relationship between fun and statistics work. And the statistical test would give you like a p-value, would give you a decision point. Yes or no. Yes, this is a significant correlation. Yes, there is a relationship. Or no, there is no significant correlation. Well, that wouldn't happen here because obviously if you do more statistics, you're going to have more fun, of course. So that would be the discussion then. And this is an oversimplified example. But in the discussion, you'd make a conclusion. You'd relate your findings, your statistics back to previous research that you might have cited in the introduction. And you say, in this case, yes, statistics are fun, of course.